Hello guys. So now we are going to discuss about electric potential due to a point charge. So let's say we have a point charge over here, is plus Q, and we are bringing another charge from the infinity point. Let's say this is point A. Make it a little bit like hello guys. So now we are going to discuss about electric potential due to a point charge. So let's say we have a point charge over here, and we are bringing another charge from infinity. So we are bringing another charge from infinity to this point. Let's say this is point A and this is point O. So at point O we have plus Q charge, and we are bringing Q naught from infinity. So Q naught is initially at infinity, this Q naught, and Q naught initially placed at infinity, and now I'm bringing the charge from infinity to point A such that we have some work done over here, and that is work done by external force. So this is the external force that we are applying, because you need to push the charge. Both charges are like charges, so you need to push the charge to bring the charge close to plus Q. Okay, so we need to push Q naught to bring it close to plus Q. So the external force applied here is called F external. Keep this thing in mind, that is called F external. You have to take a small displacement which is called dr. So let me take that small displacement. We are changing color. Let's say change the color. We can take like this color. Okay, so this is called dr. Okay, which is the small displacement. Now you can find the work done. Okay, so what is work done? How much work is done on bringing the charge from infinity to this point? You can write like this: work done by external force, and that is infinity to r, because initial distance is infinity, final distance is r, because this distance is r. What we have did here, infinity to r. Now F external vector dot dr vector. So you can clearly see it's a very simple formula of work done by the external force. Now one thing you have to keep in mind here, the external force should be equal to this force, which is called Coulomb force, because this is the only condition when you push the charge. At least you need the external force should be equals to Coulomb force. Otherwise you can't push the Q naught charge towards Q. So the minimum value required push the Q naught against Q is Fc, and that should be equals to F external. Okay, so that much minimum force at least you need. Let's say Coulomb force is 10 Newton. So minimum you need 10 Newton to push the charge Q naught towards Q. So that is a very important concept you have to keep in mind. What I'm saying actually can take like this: F external should be equals to F Coulomb. If you want to push the charge, these forces should be same. Keep this thing in mind. Okay, now why I'm taking this formula? This is another question that will arise in mind, that why I'm taking integration over here. Okay, we know that the formula of work is force into displacement. We already knew that. So why we are taking integration here? We are taking integration because here force is, keep this thing in mind, Force in this case is Coulomb force, which is K Q1 Q2 by R square. And here the force is variable. Keep this thing in mind. Force is variable. Why force is variable? Because R is variable. So for constant force, you can take F vector dot S vector, like force into displacement. But when the force is variable, so you can't find the work done directly. You need to integrate. Whenever force is variable, here force is variable. You can clearly see as you come closer to the Q, the force of repulsion will increase exponentially. That you have to keep in mind. Okay, when you come closer to, I'm drawing the graph here, short graph for the explanation. When you come closer to the charge Q, what will happen? See here. Okay, this is force versus R graph. Here force is not constant. Force is not like this. Here force is variable. How it is changing? It is changing like this. So when you come closer in this direction, what will happen? Force is going to increase. Force does not remains constant. And when anything like force changes, what you have to do? You have to integration to find the work. Otherwise, you can't find work. You can't find work by using simple formula. You have to integrate if the force is changing. Okay, there are other situations in physics in which we use the same thing. If one thing is changing and you need to find some like total value, so you need to integrate. Okay, so that you have to keep in mind. Like whenever like velocity is changing like this, let's say I'm giving you another situation, velocity is changing like this and you need to find acceleration. Let's say this is velocity, and so how you do this thing? Let's say this is velocity changing with time and you have to find displacement. What you will do? You will do dv, integration of dv, and you have some function of v, and that's how you got the value of, you need here dt, and then here function of v, and you got displacement. In like this is the situation like everywhere in physics. Whenever the things are variable, you need to do either integration or differentiation. This is one example I'm giving you. There are a lot of examples. Okay, so keep this thing in mind. So first I have to erase this thing. Okay. Okay, so now this is the situation and we have to integrate because force is variable. So let's integrate it. Work done by external force, that is equals to infinity to r, and you have here f external, then we have dr cos angle is 0 degree. Another thing I have missed here, very important, we can't put dr, we have to put minus dr, cos, that is angle is 0 degree. This is a very important point you have to remember, because here r is decreasing, so we are putting minus dr. Okay, so why we minus sign shows that r is decreasing. Very, very important point you have to keep in mind. R is decreasing. So we like this thing you can use like a lot of times we use in maths, like rate of decrease of volume. What we take? Minus dv by dr. Rate of decrease of length, we take minus dv by dx by dt. This is the rate of decrease of length. Here we need to take t. This is the rate of decrease of volume. What is the rate of decrease of area? dA by dt. Lot of example in like physics and maths, in which if they're the like rate of decrease of something, you have to take negative sign. Okay, So here we are taking negative sign. And why we are taking negative sign? Because as we come closer to the Q, as Q naught and Q come closer, so what will happen? R will decrease. That's why I'm taking minus TR. Okay, now you can solve this thing. Now you have to do integration. You'll get the answer. External force. So we have here infinity to R, and then we minus sign you can take out and just put the value of external force, that is at least equals to Coulomb force. The external force we are taking equal to Coulomb force, and now this is dr, and cos 0 is 1. So that's we got the expression of work. Now you have to integrate it and we'll get the answer. Okay, so how you integrate this thing? Okay, so work done by external force, that is minus, and now infinity to R, and you can take all the constants out. So let me take the constant like K, Q, Q naught, these are constant. R is variable because distance between the two charges is changing. There's 1 by R square and dr. Now what is the integration of 1 by R square? You all know it is minus 1 by R. Keep this thing in, very important. Integration of 1 by R square is minus 1 by R. Putting the limits, I think I have reversed the limits. Should be infinity to R. We are bringing the charge from infinity to R. Okay, you can check though in the like previous page. This is the correct limit. Okay, so now just need to put the limits. This is infinity, this is R, and we got minus K Q Q naught. Now just put the like R and infinity in this equation. So what we will get? K Q Q naught minus 1 by R minus 1 by infinity, and here another minus. That minus come from the like above, like we have minus 1 by R, so that minus will carry over here. Now minus K Q Q naught, that is minus 1 by R, and what is 1 by infinity? That is 0. So keep this thing in mind. 1 by infinity is 0. So we got work done by external force, that is minus minus plus. So we have K Q Q naught by R. And keep one thing in mind, this work done is also known as electric potential energy. So this is also the expression of electric potential energy, K Q1 Q2 by R. Now next thing what we have to do, you have to find potential. Very simple. The formula of potential is work done by external force divided by work done, let me write it clean, work done by external force divided by Q naught. So what we got? We got K Q Q naught by R divided by Q naught. Q naught Q naught will cancel out. We got the final answer, K Q by R. This is very important expression for the electric potential due to a point charge. Keep this thing in mind. In this formula, you have to take the sign of charge. Like if the charge is plus Q, take plus Q. If the charge is minus Q, take minus Q.